Welcome to session number 2, and today we are going to start looking at the code. First of all, what I want to do in this session is to take a look at the data set that we're going to be using throughout the program. And it's I want you guys to imagine that we send a delegation of scientists to Antarctica, and they go to a few islands and they start capturing information about penguins. And they, capture some measurements about the penguins, the flippers, the coleman, their body weight, and they record down the island where they found those penguins. They sent all of that data back, including the specific species of each one of those penguins. And our goal is going to be to build a machine learning model that will predict, given the data of a penguin, it can learn what the species will be. So given the body mass and the different measurements of the penguin and the island where that penguin lives, we want to predict what the species of the penguin is, okay? So this is a very simple data set. It's a very simple sample. And we're gonna use that to illustrate the entire process of building our system throughout all of these sessions, okay? So that's what the data would look like. In this second session here, I want to illustrate what the process of exploring that data looks like. And this is something that, for example, a data scientist will do at a company, right? So they go and collect some data, or maybe the company has some data, and the first thing that a data scientist will have to do is look at the data, become familiar with that data, and determine whether that data has predictive power. And that is a key phrase, right? Sometimes we have data, but that does not mean that that data is useful to predict what we care about. In our case, we want to predict the species of the penguin, but different problems, obviously, we will want to predict something different. Let me give you an example. Imagine that I give you the color of a car. So you know the color. You know the license tag, so you know exactly what the number is. You know the state where that license is registered. You know the name of the driver. You know the sex of the driver. And you know the address of the driver. You have a bunch of features, and I ask you to predict the make and model of the car. So obviously, none of those features will have predictive power. Not even the combination of those features will have predictive power to determine the make and model of the car. So that is something that obviously in this example, it's pretty self-evident, but it's in more complex scenarios, you might need to determine that. Like, can you actually build something out of these features? So that is what the exploratory data analysis process is about, okay? And that is what we are going to be doing today. So I'm gonna go here in my notebook to the second session. So this is session 2, exploratory data analysis. And I'm going to show you a few steps here. And this is just me playing out with this data set. There are a bazillion different things that you can do to analyze a data set. Every problem is different. There are many ways to slice and dice the data and to visualize the data in many different ways. Again, just, we could create an entire program just about this. I'm just going to show you a few steps here just to illustrate what the process looks like. Now, last week I was in New York and I was waiting for my daughter. She was buying books at a library. And while I was waiting, I found this little book. It's called Machine Learning, just that simple. It's a very, it's a very short book, it's a small book. The reason I bring it up here is because this book is a great introduction to machine learning for anyone who does not have experience with it. This book is not about code, okay? This is not gonna show you how to build a model or anything like that, but it will give you like a full rundown of the machine learning process, of different techniques. What does it mean to do feature engineering? What does it mean to use active learning? So this is a great recommendation for anyone who wants general culture about machine learning. So if you're that person, Great recommendation. Okay, so let's take a look at the cohort notebook here. And let's start in this cell. Let's start by just reading the data set in memory. Okay, so I'm going to be using Pandas here. Pandas is a great library to deal with tabular data. So I'm using Pandas and I'm reading the CSV file, which is our penguins data set. Remember, this is what that data set looks like. We uploaded in the previous session, we uploaded this data set also to S3. So we have it there in a bucket. But for now, we're just going to be working locally here, loading this data set in memory and displaying this data set so we can start sort of like learning what we have here. Okay, so here I read the data, and here I'm going to display the head of the data set. So basically, this is going to just display a few cells from this data set. So as you can see, I get a column for the species, and this is the target column. This is the column that we want to predict. When we train our model, we will want our model to predict this species column. So in this case, we have penguins that are Adelie. That's the species that we see here. We have an island column. So what was the location where we recorded this specific penguin? We have the culmen length of the penguin. We have the culmen depth of the penguin, the flipper length, the body mass of the penguin, and the sex of the penguin. This is all of the data that we have. And again, here I go, it just goes into an explanation of all of these columns. Every cell here comes with plenty of comments. So I added a lot of comments to every cell, so you know what's going on, so you know what I'm thinking. So if you have any questions, just make sure you read the comments here, the description between cells in this notebook, because they are going to be helpful. By the way, if you don't know what a culmen is, the culmen of a penguin is, here you have sort of like a good drawing of what that looks like. So this will be the length of the culmen of a penguin, and this will be the depth of that culmen. So just so you keep in mind what we're talking about. All right, so we already did that. I'm going to use now the describe function of the data set so I can print or display a summary of some of the statistics of every single feature in that data, every single column of that data. So I'm going to include all of the features and look at this. The species column, for example, I have 344 values on that column. For island, I also have 344 values. The unique values on species are 3. So we are going to be dealing with 3 possible species for penguins. And those are Adelie, I think Bisco, and Chinstrap. I think, or maybe Bisco is an island. I don't remember. I never remember. Oh, it's Gentoo. Gentoo is the species. So it's Adelie, Gentoo, and Chinstrap. Those are the 3 penguin species. And for the island, I think we have Torgerson, Bisco, and Dream. That's the 3rd island. So anyway, 3 unique values for species, 3 unique values for island. You can see here the number of culmen length values is 342. So that means there are probably 2 null values. See how this is 342, but we have 344 species. So there are probably 2 null values in culmen. That is important because we have to do something with missing values. What else do we have here? Look at sex, 334 values for sex. So there are quite a few. There are at least 10 missing values in sex. Not at least, 10 missing values in sex. But this is even more interesting. There are 3 unique values for the sex column. We have male penguins, female penguins, but there are 3 values. So there is something else that is not male or female. We're going to have to explore and see what that is about. You get a bunch of other statistics. What is the mean, the frequency, the standard deviation, the minimum value, the maximum value of all of the columns. So this is sort of like useful to see what's in your data, right? All right, so let's keep going down. And here I'm just going to display the distribution of the values for the 3 categorical columns that we have. We have 3 categorical columns. One is the target column, the species. One is the island, and one is the sex column. categorical here means it's a text column. It's not a number, okay? So that we use the word categoricals because they're categories. I'm displaying the distribution of these three columns. I'm using value counts, which is going to display how many values for each one of the categories. And this is what we get. For species, we have 152 Adelie penguins, 124 Gentoo penguins, and 68 chinstrap penguins. For island, 168 Bisco, 124 Dream, and 52 Torgerson. And finally, for sex, we have 168 male penguins, 165 female penguins, and we have one penguin where the sex is just a dot, right? So that apparently is a mistake. When somebody was entering this information, that person made a mistake and added a dot here. And it's really important to take a look at your data because you want to discover things like this. That's a mistake that obviously there is not a period sex for a penguin. And you want to fix that. Whenever you find these sort of mistakes, you want to clean your data. That's what data cleaning is about, right? Just cleaning all of these mistakes, fixing them. Okay, so going down, I'm just gonna fix that mistake so I can later sort of like display some charts. I don't want that incorrect sex value, so I'm gonna fix it. And I'm gonna do that just by using the replace function on that column, so I can replace any values containing a period or a dot. I want to replace them with not a number. So basically this is like the np.nan. That means not a number. It's just a null value. Okay, so I'm gonna be replacing the dot with a null value. And then when I display the distribution again, you're gonna see that that value is gone now. Now I have male with 168, female with 165, because that previous value of period is now gone. It's now a null value. Speaking about null values or missing values, we want to get rid of them. Okay, so most algorithms or most machine learning algorithms, they don't like to work with missing values. There's no information there, right? Sometimes there is information and you care about the missing value, but you don't want to just you don't want to process data that does not have a value for every single column. What we do is a process that's called imputation, or in other words, we want to replace missing values in some way. And during the live sessions, I'm spending a ton of time talking about missing values, and I'm going to show you a bunch of different techniques. Here in the notebook, just to keep things simple, I'm just going to replace any missing value with the most frequent value on that column. We're going to see that in a second. First, here, this is how you display missing values for all of your columns. So I'm saying, hey, if it's null, just aggregate all of the rows that have missing values here. And here you can see a summary. Species, we have 0 missing values. Island, we have 0. But then for column length, we have 2. Column depth, we have 2. Flipper length, we have 2. Body mass, we have 2. And for the sex column, we have 11 missing values. We need to find a way to replace all of this. Like I said, there are many different techniques. In this particular notebook here, just to keep it simple right now, I'm just going to use an imputer. And here I'm using scikit-learn, which is a framework that anyone that works in the machine learning space is familiar with. So this is a framework that implements a bunch of different machine learning techniques and algorithms and pipelines, and we're going to use it extensively here. For now, I'm just using a simple imputer. And the imputer here, the goal of the imputer is just to replace missing values using a specified technique. Here, the strategy, the technique that I'm using is the most frequent. So what's going to happen is that, for example, when we apply this to the sex column, this imputer is going to say, what is the most common value in the sex column? If I go up and we look at the distribution, you'll see that the most common value is male. So there are more male penguins than female penguins. That's the most common value. You can also see the same here in the summary statistics. The top value, you can see this line here. The top value tells us that the male value is the top value in the sex column, okay? So what's going to happen when we impute missing values using the most frequent value, what's going to happen is that we're going to replace any missing sex with male. We are making the assumption that if the sex didn't come through, then that penguin is going to be a male because that's the most common value in the data set. Obviously, I'm going to be using the same technique here for numerical values. There are better ways to do that for numerical values. On session 3, when we actually process this data set as part of a pipeline, we are going to see a different way of doing that. For here, for the exploratory data analysis, I'm going to keep it simple. I'm going to just use the imputer like this. So I'm setting up the imputer using, replace missing values with the most frequent one. And then I'm transforming the penguins data set using this imputer. I'm calling imputer.fitTransform with the penguins data set. And I'm assigning the result, which is the data set. But now with every single missing value gone, I'm assigning it back to the penguins data set. And when I display now the number of missing values, you can see that now I have zeros. All of the missing values are now gone because now they got a new value here. If I print out the distribution, so just like I did here, if I do this now, let me just grab these 2 lines. I'm going to add them here. If I print this now, I'm pretty sure it's going to say 169 male penguins because actually it's going to say more than that because we have 11 of them that we're missing. So it should say 179, I think. Let's see. Yes, 179 penguins are now males because there were 11 penguins that were, we didn't have a value for those. And we replaced all of those with males, so now we have 179. That's what happened after we imputed the missing values. Cool, awesome. So now I'm gonna go and just run or create a few charts. These are just examples. By the way, just fun stuff. I created all of these charts using ChatGPT. So I basically went to ChatGPT and I said, hey, this is my data set, and I want to display a distribution of species, like you can see here, the distribution of species, and ChatGPT generated my charts. So the code comes from ChatGPT. I had to clean it and make it pretty and whatnot, but it's just something fun that you can do as well. So here I'm displaying the distribution of the 3 categorical columns that we have. So you can see the first one is the species, the second one is the island, the third one is the sex. So now this is almost, it's very close, the number of male and female penguins. Then I'm going to display the distribution of numerical columns. So it's a pretty similar chart, but now this is just going to be focusing on the culmen and the flipper and the body mass. You can see what the distribution is. Like, for example, here you can see that the culmen goes from, about 30 all the way to less than 60. That's sort of like the length, and most of them are concentrated here in the middle. So awesome. You can display a bunch of different charts. Seeing is much more powerful than just analyzing raw data, like, looking at images. I recommend you try to display your information as much as you can. Generate charts with your information. Okay, so a couple more things that I'm doing here. I think this is really powerful. So first, I'm going to display the covariance matrix of the penguins dataset. Now, read the comment that I put here. It says, the covariance measures how changes in one variable are associated with changes in a second variable. So basically, just by looking at this matrix, it's going to tell us how 2 different variables or 2 different columns of my data are related to each other. In other words, the covariance measures the degree to which 2 variables are linearly associated. Okay, so look at this. I generated the covariance matrix for the numeric features of my data set. And I'm showing you here 3 different conclusions that you can get by looking at this matrix. This is information that's really important if you want to understand how your data works or what's in that data set. These are only 3 conclusions. You can draw a ton more conclusions. I'm just giving you 3 examples here. The first one is the positive covariance of 50.26 between Coleman length and flipper length. Okay, so let's look at Coleman length. It's right here. And flipper length, which is right here. You can see it's a positive covariance of 50.26. It suggests that larger values of Coleman length are associated with larger values of flipper length. So for those penguins that have a longer, right, Coleman, they usually tend to have larger flippers as well. That sort of like makes sense. As one increases, generally, so does the other. So that is something that you can learn by looking at this data. Here is another one, number 3. The negative covariance of negative 742 between Coleman depth, so how deep or shallow is your Coleman, and body mass suggests a general tendency that penguins with deeper Coleman weight less. That is pretty interesting, and it's not, I don't think it's, that is not an obvious thing to say, but it's pretty interesting by looking at the data that we have. So again, you can draw conclusions, you can draw insights by just printing this matrix here. And I'm doing the same thing down here with a different matrix. It's the correlation matrix. And correlation measures both the strength and the direction of the relationship, the linear relationship between 2 variables. And I'm doing exactly the same. I'm drawing 3 conclusions just by looking at this matrix. You can do your own. In this case, penguins that weight more tend to have longer flippers. That is a conclusion just by looking at this. Let's try to prove that out. Penguins that weight more, so the body mass and the flipper length. So the greater the body, look at the number. It's a positive number, 0.87, pretty high number. So the longer, by the way, the correlation here goes from 0 to 1. So and 1 meaning is perfect correlation. Okay, so you're gonna get the 1s here in the diagonal because it's Coleman length is perfectly correlated with Coleman length, obviously. You're gonna see the 1 here is in the diagonal. But body mass and flipper length is a pretty high value of 0.87, meaning the more a penguin weighs, probably the larger are their flippers. That makes sense. Bigger flippers probably increase the weight of the penguin. I also have 2 more examples here. You can draw your own conclusions from this. All right, so to finalize this exploratory data analysis, I'm going to display some more charts combining 2 features. In this case, I'm going to display the distribution of species by island, like where are these species located. And you can see by looking at this chart that in the island, the Torgerson Island, we only have Adelie penguins. That's the blue color here. Adelie penguins only show up, in Torgerson, we do not have gentoos and chinstrap. We only have Adelies. Adelies show up on every island, but there's nothing else on Torgerson. That's important. In Bisco, we have Adelies. We also have gentoos. Gentoos is primarily the type of penguin that you find in the Bisco Island. And finally, in the Dream Island, there are no gentoos. We have Adelies and we have chinstraps. Cool. Let's see the next one, which is the distribution of species by sex. And as you can see here, we have male and we have female. The 3 species, and you can see that there is really, given the sex, we cannot say much about the species of the penguin because they're pretty similarly distributed, right? Males and females, we have pretty similar distribution per species here of the sex. Okay, so again, that is the end of the exploratory data analysis. Data scientists usually do this to understand better the data set. So I encourage you to play with the data to make sure you understand every column of the data set. What do they mean? Try to sort of like visualize or understand the makeup of every column, what is the minimum value, the maximum value, what is the standard deviation of those values, because that's going to help you to make decisions later. And again, in your real application, in your real system, obviously you're not going to be working with penguins, but this is an important step to understand what you're working with. All right, so in the next session, we're going to start building a pipeline. We're going to start dealing with this data. So I'll see you there.